Sonamne. Today we'll be learning how to draw basic shapes using BIOS services in C. So our aim will be to draw hollow square using BIOS services. The program will show how low-level video handling can be done in text mode using BIOS interrupt 10H. The display will be switched to 18 to 25 text mode. So in this text mode, the display gets divided into rows and columns, and characters are printed at the desired screen locations to form the outline of a square. Cursor movements and character display are controlled using BIOS functions. So we'll be seeing the objectives and outcomes now. The objectives will be to learn about how low-level graphics programming and hardware interaction by utilizing BIOS interrupt 10H, and to understand how to manipulate CPU register for calling BIOS functions to draw. The outcomes will be we'll learn to draw various shapes like lines, rectangles and circles, and gain some low-level programming skills. So we'll first see the function 00H, that is the set video mode. It is a function used to set the display mode of the screen. When we store the 00H in AH, it tells that we want to set the display mode of the screen to video mode, and AL stores the mode number of the mode number, that is which video mode we are going to use. So it changes the screen to specified video mode and clears the screen. So some of the common mode numbers are 0 through H, that is the color text mode, 07H, that is monochrome text mode, and 13H, that is the graphics mode. So we'll be using the text mode in our code. Some more functions are function 02H, that is the set cursor position. This function moves the cursor to the specified row and column. It uses AH to store the function number, BH to store the page number, usually 0, that is the default page, DH row number, that is the Y coordinate on the screen, and DL stores the column number, that is the X coordinate on the screen. It moves the cursor to the specified row and column on the screen. This is required to move the cursor to the specific row and column to print the character at that position. Now function 09H, it is to write character and attribute. It prints character at that cursor position. It uses AH, which stores the function. AL stores the character, which character we want to print, and BL stores the color attribute. And CX will store the count, that is how many times we want to print the given character at that position. The procedure is as follows, that is first set the video mode, that is text mode, using the interrupt 10H and function 00H, which also clears the screen. Define the shape algorithm. Here we are going to draw a hollow square, so we will write the algorithm for drawing the top, bottom, left and right edges of the square. Then move the cursor to the specific row and column positions using the interrupt and the function 02H. Print characters with attributes, that is colors, at the cursor location. We will use the function 09H. Repeat the process for all points that forms the square and wait for key press so that the output remains visible. So we'll start with the code. The code starts with including the DOS header file. As C can't directly access CPU registers, it allows to access BIOS DOS interrupts. We are using int 86 and union registers, which both are defined in DOS header file. Now hashtag include conio.h. This is to include the conio header file, which contains a getch function. Next is this union registers. It is a union to let you set CPU registers in C. It has two main views. .x, here we are using this union. Here we are using .h to access 8-bit registers such as AH, AL, DH, DL, BH, etc. And when we use here .x, it accesses the 16-bit registers AX, BX, CX and DX. So first we'll see the function to move the cursor to the row and column, that is void set cursor function. It will move the cursor to the row and column. Here we are storing 02 in H, which tells BIOS we want to function 0 to h of interrupt 10h, which is the set cursor position function. BH will store 0 in BH, that is the page number. DH is equals to row. DH will store the row number and DL will store the column number. Here we are calling the int86 function, which calls the interrupt 10h, pass this register values and also stores results back in this register values. It takes the interrupt number 10h, that is the BIOS video interrupt. Now next is the function to plot character at row and column. So for printing the character at the specific row and column, first we need to move the cursor to that row and column. So we are calling here first the set cursor function, which will move the cursor to the specified row and column. Next we are again storing 09 in AH, that is the function write character and attribute. And next is that we are storing character in AL register, and again storing page number 0 in BH. BL will store the color attribute. CX is equals to 1, which tells us that we want to print the character only once at that specific position. Again we are calling the int86 function and passing these register values. This function will store back the result in these registers. Next is the function to draw a hollow square in this text. We are passing row, column, size, color and character. Here normal variable declarations are done. We are using two for loops. The first for loop is to draw the top and bottom edges, and the next for loop is to draw the left and right edges. We'll first see main function for this. We are keeping the size as 4, row 5, column 10 and color 15. Character we are taking asterisk, color 15, which means we want to use white color. Here we are setting the function mode 0, that is we want to set the display to the video mode, and that is text mode here 03h. int86 calling the interrupt, passing this register values and storing back there. So after this the display will get divided into text mode, get divided into row and column as in text mode. Then we'll call the draw text square function, passing these values, that is 5, 10, size is 4, color white and character asterisk. So this will get called. So this first for loop will work. C will go from column, that is 10, this value is 18, so at 18 the condition will get false, so C will run from 10 to 17. For first value of C, that is 10, this function will get executed, that is row 5, column 10. So character gets printed at 5th row and 10th column. So when this function is getting called, it will first move the cursor to that position and then print the character at that position. Then second function, this call will get executed and it will print the character at 8th row and 10th column. So the output will look like this. First, for the first iteration of loop. Then for C is equals to 11, it will print at row 5, column 11 and row 8, column 11. Similarly, it will go till C is equals to 17, and this will be the output of the first for loop. At C is equals to 18, the condition gets false and the loop will exit the loop. The next for loop is for the left and right edges. So here R is equals to row, that is R is equals to 5 to, it will run till row plus size, that is 9. So R will go from 5 to 8. For R is equals to 5, it will call the putChar function and it will print character at 5th row and 10th column. As we have already printed the character at that position, there will be no such visible changes, as you already character is printed. Next will be for R is equals to 6. Here it will print character at row 6 10th column and 6th row 17th column here. For third iteration it will print asterisk at 7th row 10th column and 7th row 17th column. For r is equals to 8, already at row 8 and 10th column asterisk is printed, so no visible changes. Here also it is already printed. So the final output of our code, of our program. So we'll see what's the output of the program. Here I have typed the code. Yeah. See, the same output is coming. So the program demonstrates creating a hollow square using BIOS in C. It shows how cursor positioning and character printing can directly control the screen. We use the functions 02h 09h to move the cursor to the specific position and to print the character at that position with the attributes. It highlights the low level interaction between the software and hardware. Thank you.